Welcome to our comprehensive guide on setting up your development environment for multimodal model fine-tuning. A proper setup is crucial for successful model training and deployment. We'll walk through each component systematically to ensure you have a robust foundation for your work. Our learning objectives focus on practical, hands-on skills. Each objective builds upon the previous one, ensuring you have a solid foundation for working with multimodal models. We'll cover both basic setup and advanced configurations to handle various use cases. Hardware requirements are crucial for successful model fine-tuning. The GPU requirement is particularly important. We recommend at least 24 GB of VRAM to handle modern multimodal models efficiently. The specifications listed are minimums. More powerful hardware will improve training speed and efficiency. Our software stack is built around Python and key machine learning libraries. Each component plays a crucial role: Python as our base language, CUDA for GPU acceleration, PyTorch for deep learning operations, and Hugging Face libraries for model handling. Version compatibility is crucial for stable operation. The installation process follows a specific order to ensure proper dependency management. We start with PyTorch as our foundation, then add Hugging Face libraries. It's important to use the specified versions to maintain compatibility. The visualization shows the linear progression of our installation process. Environment isolation is crucial for maintaining reproducible setups. Each approach has its benefits: virtual environments for simplicity, Conda for comprehensive package management, Docker for complete isolation, and cloud environments for scalability. Choose based on your specific needs and team requirements. Proper authentication is essential for accessing models and resources. The Hugging Face token provides access to models and the hub, while other credentials may be needed for cloud resources. Always follow security best practices when handling credentials. Validation ensures your environment is properly configured. We'll test each component individually: GPU connectivity, library functionality, model loading capacity, and memory management. This systematic approach helps identify and resolve issues early. Understanding common issues and their solutions will save valuable time during development. Each problem has specific symptoms and solutions. We'll look at systematic approaches to identifying and resolving these issues efficiently. Optimizing your environment for performance is crucial for efficient model training. We'll explore various techniques to maximize resource utilization while maintaining stability. The graph shows how proper optimization can significantly improve training efficiency. Following best practices ensures a maintainable and reliable development environment. Regular updates keep your environment secure and compatible, while proper documentation helps team collaboration and troubleshooting. As we conclude, remember that a well-configured development environment is fundamental to successful model fine-tuning. Take time to properly set up and maintain your environment, as it will save considerable time and resources in the long run.